Alright, so in this video, we're going to talk about the difference between a nodal and a ventricular action potential in the heart. So we have the SA node and the AV node, and those are going to have they're going to have different channels opening at different times compared to the ventricles. And this is because the nodes are the pacemaker cells of the heart. So that means pacemaker meaning that they don't have necessarily a resting membrane potential. So the potential is constantly rising or falling. Versus the ventricular action potential, you're going to see that it has a resting potential, and then it rises, then falls, and then rests, and then rises, and then falls. So let's go through each one, and we'll compare the two at the end. So starting with the nodal, first we're going to start with, there's three phases that we have to know. So we're going to start with the rising phase, and that one's phase 4. So if we draw a line up, and this dashed line is the threshold for an action potential. So phase 4 is just a slowly rising, right? You see how it's not straight up. So it's a slowly rising depolarization, and that one's caused by what we call the IF current, or the funny current. And it's funny because there's no rest. So it's constantly thinking about constantly trying to be funny, constantly having to depolarize the cell. So what happens is sodium will go in and potassium will go out, right? And so the net effect is sodium, there's more sodium going in, and so you'll have net depolarization, and that's why you see this climbing depolarization for the beginning action potential. Okay, so that's the funny current, and that's phase 4. So we'll label that one 4. Okay, and then the next part, so now we've reached threshold. So what happens immediately after you reach threshold? It spikes up, right? Spikes up like that. Okay, so how did we get there? Well, we had the funny current, but we also had two other channels that opened up. So the first one we have, it opened up, let's say about here, and that's going to be the calcium channel, specifically the tiny ones. And then another calcium channel here, and that's the large ones. Tiny meaning they're transient, so they are engaged earlier than the large ones, but they don't have as much of an effect as the large ones. And so that's why you see after the larger calcium channels open, they last longer, and that's what causes that spike here. Okay, and so that spike, that is phase 0. So they're not really in order from 1, 2, 3, which is not very nice, but that is phase 0, and you're gonna see it's the same in the ventricular action potential, also going to be phase 0 for the spike. Okay, so after the spike, what's the next step? Well, it has to come down. And so in both, you'll see that the come down for the nodal looks like this, and it's going to be different in the ventricular. And so this is due to the potassium channels, so the IK channels. So it's like IKR and IKS. You don't really have to know the difference mainly, but specifically for this, both of them open, and that's why you get potassium out of the cell, causing hyperpolarization. And so this is this downward trend, that is number 3. So we have 4, 0, and 3. So those are the 3 that you have to know. And then after that, it just repeats. So it'll come down, and then you see how it curves up? Because there's no resting for the nodes. They're pacemakers, so they're constantly having to fire. And so it's slowly going to come up, come up, come up, come up with the same funny current. So the funny current is also here. And then it's just going to repeat. Okay, so now let's compare it to the ventricular action potential. So the ventricular one is a little different. So first, it starts with the resting. So the resting is down here, and that one also starts with 4. So that's 4, but that is not necessarily, that's not the funny current. This is the inward rectifier potassium channels. And so those maintain the resting potential in the ventricles, right? So these are the muscle cells of the heart. Okay, and so that's number 4. Then, just like here, what happens after 4? 0, which means there has to be a spike. So there's a spike here, and so after the spike, now we need to repolarize, right? So this kept the membrane potential low, so it's resting. Potassium channels are opening, and so there's no depolarization going on. Then you have the depolarization, right? And so we said that one was phase 0. So that's 0. And which channels are opening here? So over here, in the nodal, you have calcium and calcium. First the tiny ones, and then the large ones. And then you have the spike. However, in the ventricles, it's not calcium. Instead, it's sodium. So here you have fast sodium channels. They're opening, okay? And so the sodium channels are opening, and there's a lot of sodium channels, and that's why you get this huge spike. Okay, now we have to repolarize the cell. So this repolarization stage is a little more complicated than just going down, like in the nodal. So first we have a small dip, and that dip, that's a potassium channel. So that's the KITO, the ITO channels. And so that's just part of the initial rapid repolarization phase. Okay? And then, so we'll label that, so that's 1, that's phase 1. So you can think about it as phase 1 of repolarization. Okay, then the next phase, you have just a downward trend, kind of like that. And that is called the plateau phase, and that's phase 2. So in the plateau phase, you have calcium influx, plus you have the IKR and IKS. So you have calcium influx plus IKR, IKS, right? And so you have, so overall that means you have the cells hyperpolarizing by potassium leaving the cell, and then the calcium is staying inside the cell, but the net effect is hyperpolarization because you have more potassium leaving, right? And that's how a cell hyperpolarizes, like here. Potassium left and it hyperpolarized. So same thing here. So you have the cells hyperpolarizing, and it's going to keep going, and eventually calcium's not going to be involved anymore, and it's just the IKR and IKS. And it looks like that, and then it goes like that. And so this, just like in nodal, is phase 3. And so this is IKR, IKS, they're just potassium channels. And then once that has reached the baseline again, then you're back to 4. And so which cells, or which channels are open here? It would be the inward rectifier potassium channels. So that's called KIR. And those just help maintain that baseline. So the main difference between the two really is on the left they have the nodal has the funny current, because you have to constantly have the pacemaker cells working and having their voltage changing, because without them then the heart wouldn't be able to start, right? Starting from the SA node to the AV node. Versus the ventricles, the muscles are just waiting. They're waiting for an action potential to reach them. So they don't function as pacemaker cells necessarily. So that's the difference here. And then for the upstroke, you have calcium channels with the nodal, sodium with ventricular. And then for repolarization, there's 3 steps versus just the 1 step. And remember, it's calcium's involved in the plateau phase. Okay? And the calcium channels that are involved are going to be the large ones. That's something I should include. So these are going to be the large ones. So the tiny and transient ones here in the nodal, they're not in the ventricular. And that's it.